Question 1. Okay, applying exponent properties.
Whoa.
What are products? Multiplication. Product is multiplication. What is an exponent?
Isn't it like a little number that you put beside, or beside a number that shows that you're multiplying that number by itself?
Right. It tells you how many times you're going to multiply a number by itself. Okay. How many times you're going to multiply a number by itself? The big B is called the base. Little e is called an exponent. The entire thing, you know how you have multiplication, division, addition, subtraction? The entire thing is called a power. Okay, what we're doing is we're taking a power. Okay, addition, subtraction, multiplication, division, well, power. Order of magnitude. The order of magnitude of a quantity is the power of 10 nearest to quantity. Now, I'm not so worried that you know what that means. That's just new. That's just, you're not thinking that. Now,
What's that?
I will see. We'll just take a picture of it. Product of powers property. Okay. Now, I'm not so worried that you know what the property is called as what you know what the property does. Okay. If A is a real number and M and N are positive integers. Okay. What's a real number, first of all? Anybody remember what a real number is?
1, 2, 3.
Yeah. 4. It's any number you can think of. Is 3/4 a real number?
No.
Sure it is. It's a rational number. It's a real number. Okay? It's any number. An integer, now, Bear, what's an integer?
It's a number.
1, 2, 3, 4, 5, 6, 7. It's the one you were thinking of. Real number is any number you can think of.
Negative.
Okay? Yeah, negative, positive, doesn't matter. Pi, anything you can think of is a real number.
Is negative 2 an integer?
Negative 2 is not an integer.
Is it only?
1.
Oh, yes, it is. I'm sorry. Yes, it's an integer. Yes.
So it's just solid number.
Right.
Not left over.
Not, yes. So, for instance, if you have two numbers with the same base, what do? Add the exponents. So, do you see how these A's are the same? Okay, that means I can take M and N and add them together. Now watch, do you understand why that works? Let's do that. Let's do an example over here. We have 5 to the 6th times 5 to the 3rd. 5. 5. For some reason it won't work. 5 to the 6th times 5 to the 3rd. Maybe if I use my notes. Okay, suppose I have 5 to the 6th times 5 to the 3rd. Why does it work that I can add the exponents? Well, what is 5 to the 6th?
5.
5 times 5 times 5 times 5 times 5 times 5. Okay, so I have 5 times 5 times 5 times 5 times 5. 1, 2, 3, 4, 5, 6, right? Yeah. What's 5 cubed? 5, 5, 5, right? How many 5s do I have? It's just all multiplication, right? I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's just 5 to the 9th power. Well, what's another way to do that? Just take your 5 and add 6 plus 3, get 5 to the 9th, instead of writing out every single stinking 5. Does that make sense? Okay?
When we do like homework,
Yeah.
does it have to, like, if it says 5 over 6 times 5 over 3, you want us to put equals 6 plus 3 equals...
No, you don't have to write that middle set now.
Okay.
Okay? Now, go back to my note-taking guy here. That's all this is saying. You can add these exponents, but only if that 5, see how those bases are the same?
That's a big number.
Okay? You can only do it if the bases are the same. Okay? So, for instance, if you have... Come on, work. We'll just keep going on the note-taking guy. Okay, use the product of powers property. So basically use that, what we just learned, okay? Simplify the expression. 2 squared times 2 cubed gives me 2 to the 2 plus 3 to the 5th. I just added the exponents. Same thing here. I have w to the 9th times w squared times w to the 7th gives me w to the 18th. Just take 9 plus 2 plus 7. C to the 4th. Now, times 4. What is the imaginary exponent here?
1.
1. So then how many 4s do I have? 5 of them. So it's 4 to the 5th. Then here I have negative 6. Remember, there is an imaginary 1 in here. That's why they did these on purpose. When you write it out, it's not going to be there. But there is an imaginary 1 in here. That's what they wanted you to write it here. This is to the first power. Then you add the exponents and get negative 6 to the 7th. Good? Does that make sense? Kind of? All right. Power of a power. This is different than multiplying. This is, if you have a base, or if let A be real numbers, so this is just any number you can think of, and M and N are positive integers. So basically they're positive, they're whole numbers, positive integers. Okay? To find the power of a power, multiply the exponent. So when you have a power to a power, you multiply them. When you multiply two exponents with the same base, you add them. You see how this is a power to a power? Now I'm going to explain that to you. Why in just a second. Watch. You have 5 cubed squared. I'm going to work the outside in. Isn't this just 5 cubed times 5 cubed?
Yeah.
Because I'm taking 5 cubed and I'm squaring it. 5 cubed times 5 cubed. Well, we already know 5 cubed times 5 cubed is, what do we do with the exponents?
I think it's 3 times 3 and 3 instead of 3 and 2.
What?
2 and 3, 3 instead of 3 and 2.
Okay, I'm taking 5 cubed and I'm squaring it. Meaning I have to write this out twice.
Oh, okay.
Does that make sense?
Yeah.
So now what did we already learn about when we multiply two bases or two powers with the same base? What do we do with the exponents?
You add them?
You add them. So you have 5 cubed plus cubed. So it's 5 to the 6. Well, if I could have just taken this and gone 5 to the 3 times 2, would I have gotten the same answer?
Yeah.
Yeah. So when you take a power to a power, you multiply them. When you're multiplying them like this, you add them. Does that make sense? You see the difference. This is a power beside a power. A power to a power. You multiply it. Okay? A power times a power with the same base, you add them. Okay? Let's keep going. That's all this is saying. So this just gives me a to the m times n. 3 to the 4th squared is 3 to the 8th. Now, we're just doing examples. Look at A. I have a power to a power, so it's 5 to the 3 times 2 is 6. 5 to the 6th. Part B, n to the 7th squared to the 7th squared, I'm just taking n to the 7 times 2, which is 14. Any questions? You guys with me so far?
Mm-hmm.
Fair? Okay, I'm just multiplying exponents. I still have negative 3 to the 5th, and then cubed, so I just multiply them and I get negative 3 to the 15th power. Same thing here. Even if it looks ugly like this, z minus 4, you still can multiply the exponents. Z minus 4 to the 10th. Okay? Power of a product property. This property just means that you can distribute a power or an exponent. Okay, this just means you can distribute an exponent. Let A and B be real numbers and let M be a positive integer. To find a power of a product, find the power of each factor and multiply. What does that mean? Look, what did they do to that M? They just distributed it. Okay? They just distributed the M, A to the M, times B to the M power. So if you look at this one, you can take 23 to the 5th times 17 to the 5th. you distribute your exponent. Exponents are distributable, if that's even a word. Okay? Do you understand? Questions? Use the power of product property. If I have 4 times 16, all to the 7th power, you can distribute the 7 to each part. Same thing here. Now, be careful here. Because you have to, if you have -3 RS, you can't just distribute to the R and the S. That's the #1 student mistake. You have to distribute it to the -3 as well. So I have -3. You see how -3 squared times R squared times S squared. Well, what's -3 times -3? -3, negative times negative gives me a, yeah, so I have +9 R squared S squared. The reason they did this is they want you to see the difference. Okay, this is going to give me a negative answer because I'm distributing my square to the 3, the R, and the S, not the negative because it's outside the parentheses. You see how it's outside the parentheses? So that just gives me -3 squared times R squared times S squared, which 3 squared is 9, but then I have that negative outside the parentheses. That's just like times -1. You see why this one's negative and this one's not? That's why they did that example. I really like that. You need to see the difference here. The negative is on the outside of the parentheses for this one. It's on the inside of the parentheses for this one. Keep going. Okay, check. See if you know what you're doing. Did you get -7 to the 13th, k to the 6th, q to the 12th? Q plus 8 to the 12th. They multiplied 6 times 2. They distributed 8 times 8 is 64. C squared, B squared. And then I have the negative outside the parentheses, so 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125. Z cubed is distributed to that Z, and then that negative is on the outside, so it has to be a negative. Okay? So let's look at the next example. Now, we're going to use all these properties to start simplifying stuff. Okay? Now, the first thing I have to do for this one, since the bases are not the same, this one has an x, and this base is a 3xy, I have to first distribute this 3. Okay, and that's what they did. They said, okay, here's x squared, but then let's say we have 3 cubed times x cubed cubed times y cubed. Here's the part that's difficult to see. Right here. There we go. Now it's working. Make sure you see this right here. We have x cubed cubed. So what are we going to do to the powers? Or the exponents? Multiply them. Okay? We're going to add them here in a second. I'll show you when. Okay, so I'm going to get x to the 9th. Right? 3 times 3 gives me x to the 9th. So I have x squared, which is out here, okay, times 3x cubed y, or 3 times 3 is 9, times 3 is 27. That's where I get this one. Okay, 3 times 3 is 9, times 3 is 27, times x to the 9th, y cubed. I'm not as worried that you know these, okay, as I am that you can do the example. Okay, those aren't important until you do proofs next year in geometry, if you take geometry. Okay? So now I have this all written out. Do any of them have the same base?
Yeah.
The x's have the same base, so what do I do since I'm multiplying them? Now what do we do, Nika? Now we add them. So we take 9 and 2 and add them, we get 11, so we have 27x to the 11th, then just y cubed out there. I can't add that to anything. The base is the same as anything else. Okay? Now let's do, everybody do the checkpoint if you didn't do it yet. Okay, I'm not going to show you the answer. I'm not going to show you the answers if I don't help it. You didn't, if you did it already, that's great. If you didn't, quick do it. And we'll show you answers. Why doesn't it go in there? You're getting angry with me, huh? Here we go. If you didn't do the checkpoint yet, do it right now.
I show you the